In this video we are going to discuss about Ebers Moll's model of bipolar junction transistor. So let me take a PNP transistor. This transistor consists of two PN junction diode. Here you can see the base region is common to that of emitter and collector, and it is form a coupling between the emitter and collector. So this emitter, this base is a narrow region, so therefore there is a electrical interaction exists between this junction. So this interaction is called as a transistor action. So let me draw on two diodes. Okay, this is a PN junction diode and this is also a PN junction diode. This is emitter, collector and base. So across this emitter and base you have a voltage called VEB. Across the collector and base you have a voltage called VCB. And IE is your IE is your emitter current, IC is your collector current, and IB is your base current. So assume there is no voltage drop across all semiconductor forming the emitter, base and collector region. Therefore REE and RBB and RCC bar is equal to 0. So here the I can write this IF. IF is the emitter base, the current is a forward current, and this alpha IR is a portion of the collector base diode current which is coupled to the base and base to the emitter. And likewise alpha F IF is a portion of the emitter base diode current which is coupled through the base to the collector. So by applying the KCL, Kirchhoff's current law, I can write IE. What is IE? IE is IE and I alpha or IR is incoming current and IF is outgoing current. So I can write IE is equal to IF minus alpha or IR. So what is IF? IF is a forward current. So that is between emitter to base. So I can write IE naught. IE naught e power VEB divided by VT minus 1 minus alpha or IR. So what is IR? IR is a the current which is flowing through the collector to base. So this is nothing but IC naught e power VCB by VT minus 1. Here I have make it eta is equal to 1 for germanium. Okay. So similar way I can write it for IC. IC and IR is outgoing current and alpha IF is incoming current. So I can write IC is equal to alpha F. Instead of IF I can write IE naught e power VB divided by VT minus 1. Instead of IR I can write IC naught e power VCB by VT minus 1. In a similar way I can write this IB. IB is outgoing current. This 3 also is outgoing current. And you can see IF and IR is a incoming current. So I can write IB is equal to IF plus IR minus alpha or IR minus alpha F IF. So in that I can take IF common. I can write IF minus alpha or IR minus alpha F EF minus IR. So what is alpha F minus alpha or IR is IE. Alpha F IF minus IR is IC. So I can write I is equal to IB plus IC. So we know that for the active region, this emitter to base junction is the forward bias, and collector to base junction is reverse bias. So I can write IE. What is IE? This is alpha F minus alpha IR. This IR should be instead of IC naught e power VCB by VT minus 1, you have to substitute minus IC naught. So if I substitute, I will get plus IC naught here. Okay, since I have applied a reverse bias to the collector base region. So you have this component and this component, right? So similar way I can write IC is equal to IC naught plus alpha F IE naught e power VEB by VT minus 1. Why? You have this region. This region is a reverse. This is a forward bias and this is a reverse bias. Since it is a reverse bias, you have only this one. Okay, this becomes IC naught. Okay, minus IC naught. So you will get plus IC naught. So we know that alpha or IC naught is equal to AQ dP Pn naught divided by W. Alpha F is equal to alpha F IE naught is equal to AQ dP Pn naught divided by W. So both the equation are same. So that is, I can equate it into IS. So from this equation I can write IE naught is equal to IS divided by alpha F, and IC naught is equal to IS divided by alpha R. So I am going to substitute this equation, these two values in this equation. So you will get IC is equal to minus IC naught so IE is equal to IS divided by alpha F into e power VEB by VT minus 1 minus IS e power VCB by VT minus 1. So similar way IC is equal to minus IC IS divided by alpha R e power VCB by VT minus 1 plus IS into e power VEB by VT minus 1. So we know that IE is equal to IB plus IC. So to get the IB value, you have to subtract IE from IC. Sorry, IC from IE. So you substitute these two equations here, and therefore you will get IS e power VEB by VT minus 1 into 1 divided by alpha F minus 1 minus IS e power VCB by VT minus 1 into 1 minus 1 divided by alpha R. So we know that alpha is equal to beta divided by 1 plus beta, and 1 by alpha is equal to 1 plus beta divided by beta. So this I can write it as 1 by beta plus 1. So what is 1 by alpha minus 1 is 1 by beta. So I can substitute this whole term as 1 by beta F. Okay. So here the alpha F significance, it is nothing but alpha F is forward transmission from emitter to collector. This is also called as common base current gain. Okay, common base current gain, and its value is 0.98 to 0.998. Okay. Similarly, what is alpha? Alpha is a inverse alpha of a transistor. It ranges from 0.4 to 0.8, and it is called as reverse transmission from collector to emitter. So I hope this video will be useful for you. Thank you very much for your patient listening.